morning, Algebra 2. It is nice to see you guys. Not really, I'm not here, but here is your video for today. And actually it's two sections, 1.8 and 1.9. Let's go on ahead and talk about vertical asymptotes and domains. So you guys have been working with functions for quite a while now. Asymptotes is nothing other than factoring and simplifying. Okay, so let's go on ahead and take a look. So a rational function is a function whose rule can be written as a ratio of two polynomials. The parent rational function f of x equals 1 over x. So that's this graph right here. Okay, so that's the reciprocal function, which we talked about at the beginning of the year. So its graph is called a hyperbola, and we've talked about hyperbolas, which has two separate branches. Okay, so it's got this branch over here and it's got this branch over here. So it's essentially two parabolas facing away from each other. Okay. Like logarithmic and exponential functions, rational functions may have asymptotes. So remember that an asymptote is a line that this is going to get closer and closer and closer to, but never actually touch. So here, there's one of our asymptotes, and there's another of our asymptotes. Okay? So this function has a vertical asymptote at x equals 0, so this vertical one, and it has a horizontal one here. Okay, so right now in 1.8 we're going to talk about vertical asymptotes and how you find those. Okay, so it says make sure the rational function is simplified. In other words, we simplify it to the most simplified version, and then we want undefined values. Okay, those undefined values, which is where the denominator equals 0, every part of it, are all vertical asymptotes. So it can have more than one vertical asymptote. Okay, so the domain will be all x's except x cannot equal h, where h is an undefined value. So that's what this means. So this means all x's, okay? So all x's are all real numbers, okay, except for this value right here. We're going to write it in that set notation. Okay, so let's go on ahead and let's find some vertical asymptotes here. Okay, so the first thing we need to do is make sure that this is simplified. There's nothing I can cancel. There's nothing that I can factor, so this is simplified. All I care about for vertical asymptotes is the denominator. So I'm going to take that denominator and set it equal to 0, and I'm finding my undefined values. So we've been doing this all along. We've been saying, hey, x cannot equal this value. Okay, so plus 2. So we get x cannot equal 2. Well, that's our vertical asymptote right there. So now all we're going to do is we're going to write it in set notation. So we're going to have x, so all x values, except x cannot equal 2. Okay, and that is our horizontal asymptote. Our vertical asymptote. Okay, so let's go on ahead and do the next one. So we need to simplify it. So x squared minus 4 is a difference of squares. So that becomes x plus 2 times x minus 2. Okay, so now we're going to take these values, so we can't cancel them. There's nothing we can get rid of down there. Okay, and we're going to go on ahead and set each of those equal to 0. So x plus 2 equals 0, x minus 2 equals 0. Okay, and we're going to go on ahead and solve, and we get x equals negative 2 and x equals positive 2. Okay, so those are our undefined values. So those are what x cannot equal. So now we're going to write this in set notation. We're going to say, okay, our domain is all values of x except x cannot equal plus or minus 2. And you could write negative 2, comma, positive 2, right? But I just wanted to simplify it and just write plus or minus 2. So let's go on ahead and we will take a look at the next one here. Okay. So just going to look at the denominator. First we're going to simplify it. So it multiplies to negative 15 and adds to negative 2. It's going to be x minus 5 and x plus 3. Okay, so we're going to set both of those equal to 0, and we get x cannot equal 5 or negative 3. Okay, I just solved it in my head real quick. Now we're going to write it in set notation. Okay? So all values of x except x cannot equal 5 or negative 3. Okay, so those are our two vertical asymptotes. If we were to graph this thing, whatever this graph looks like, we would have an asymptote there. Okay? So where x could never touch, okay, where the graph could never touch. Okay, so this one right here, let's take a look. So this is still a rational function. Okay, it's still that parent function 1 over x. Okay, but we've added a k at the end. Okay, so keep in mind that this is really a, right, times 1 over x minus h plus k. Okay, so this is our vertical. So we don't really care about that for our asymptote, for our vertical asymptote anyway. Okay, so here we're just going to look at the denominator again. So x plus 3 cannot equal 0. Solve it and we get x cannot equal negative 3. Okay. So now x, all values of x except x cannot equal negative 3. Okay, we didn't have to do that plus 7 for anything. Okay. So now we're going to go on to section 1.9, which is dealing with more asymptotes and holes, okay, where the graph does not touch. Okay, so we have a couple of different things. Positions of the variables in a rational functions equation tell you about its graph. Okay, so if it has variables in the numerator, that means those are zeros for some values of x. In other words, its graph has zeros, points where the curve touches the x-axis. Okay, so remember that zeros, if I have a parabola, right, my zeros are right there, touching the x-axis. Okay? So that's what our numerator tells us. If it has variables in the denominator, okay, it's undefined for some values in x, and it means that it's a vertical asymptotes, lines that the curve gets close to but never touch. Okay, so these curves are never ever going to touch those vertical asymptotes. Okay, so if I have a graph and I have a vertical asymptote there, you know, this graph will get closer and closer and closer, but it's never actually going to touch that line. Okay, so let's follow these steps. And it says to make a sign chart for the function. So this is just a way to graph it. Okay. And you can do it this way, you can do it, you know, a different way. This way's pretty easy. Okay, so it says the first thing, we're going to find any x values that make the numerator equal to 0. Okay, so in other words, we're going to have x minus 1 equals 0 and x plus 1 equals 0. If we need to factor it first, we're going to factor it first. So here we're going to get x equals positive 1 and x equals negative 1. So now we need to find our vertical asymptotes. So we're going to find any x values that make the denominator 0. Okay, so here we're going to take this denominator and we're going to have x minus 2 equals 0 and x plus 2 equals 0. So our asymptotes are at 2 and negative 2, and those are our vertical asymptotes. Okay, so now we're going to use a sign chart to graph the rational function. I don't mind if you use your calculator to graph it, but you need to show me by hand this work. Okay, you can't just graph it on your calculator and then tell me. You need to actually set these equal to 0 and solve them. Okay, you can use your graphing calculator to actually draw the graph and to check it. Okay, so we know that negative 2 is undefined and positive 2 is undefined. So those are our asymptotes. Okay, so this has you drawing this sign chart. I don't ever draw the sign chart. Okay, so let's just go on ahead and draw our graph. And you can just do it there if you want. Alright, so we know that at, let's see, 1, 2, 1, 2. So at positive 2, there's a vertical asymptote, and at negative 2, there's a vertical asymptote. We know that at negative 1, our y value is 0, and at positive 1, our y value is 0. So now what we need to do is we need to figure out what's going on with this on either sides of those. So that's why we're plugging in a value over here, negative 3, and a value over here, okay, negative 2. And then 0, we need to find out what's going on with it so that we can find out what goes on, if anything, here in the middle. Okay, so really we're just plugging in. Okay, so if you plug negative 3 in here, okay, into this function that we started with up here, this x minus 1 plus x plus 1, x minus 2 times x plus 2, and you're going to get 8 over 5. Okay. 5 is a little more than 1, so that's going to be up here somewhere. Okay, and if you continue plugging, you know, negative 4 in, negative 5 in, you're going to see that it gets smaller, so it's going to look like this. Okay, and that's why I say you can graph it on your calculator, okay? But you need to make sure that you're showing me all the work, and you have to make sure you know how to plug it into your calculator correctly, because if you don't use the correct parentheses, then you're going to get the wrong. Okay, so if you're graphing this on your calculator, you need a pair of parentheses around all of that, and then the division sign, and then you need a parentheses around all of that. Okay. Alright, so if you plug negative 1.5 in, you're going to get negative 0.71. So here, it's going to be somewhere down here. Okay. 0 gives you 1/4. So we know it's going to be up here somewhere. And then 1.5 should give you negative 0.71 again. Okay, so we're going to be somewhere down here. So this middle piece, we know then goes like that. Okay. And then our other piece, we're going to plug in a point on this side, and we get 8 out of 5 again. And if we continue plugging in points, okay, we know it's going to look something like that. Okay. So, and I probably drew that a little bit shallow. Okay. But it's a sketch, right? So I want, you know, some of your points to be on there. Okay, but the majority of the thing can just be a sketch. Okay? So the other way to do this, you know, it says make a sign table. The other way to do this would just be to make an X and Y. You don't have to include these values if you know what they are already. Okay, but you need to include some on the left side, some in the middle, and some on the right side. Okay, so that's what making a sign chart is. Okay, but that's not all that there is to it. So some of these get a little bit more difficult, and we already did this, so on that last one. Okay, all right. So now we're going to talk about horizontal asymptotes, and then we're also going to talk about holes. Okay, so horizontal asymptotes there's 3 different things. If the fraction is top-heavy, meaning the exponent on the top is greater than the largest exponent on the bottom. Okay, then that means that there is none. If the fraction is bottom heavy, okay, so in other words, the exponent in the denominator is larger than the exponent in the numerator, okay, then you're going to have an asymptote at y equals 0, and that's horizontal. Okay, and then the last one is going to be if they're the same degree. So the exponent is the same, the largest exponent on the top and the bottom. Okay, then it's just going to be the coefficients over each other. Okay, so let's take a look at that. So here it says find the horizontal asymptotes of the following. Okay, so 3, that would be an x to the 0, in other words, no x's, and that's an x to the first. Okay, so this one is bottom heavy. Okay, and using our chart here, and you guys do need to memorize this, and you know that y equals 0. Okay, so that's our horizontal asymptote right there. Okay, so here, all we're looking at are the values. They're the same. So it's going to be negative 5 over 2. Okay, we're not going to factor this right now. Okay, the first thing we're going to do is we're going to look at this. So we're going to say x squared over x. It's top heavy. So that means that there is no horizontal asymptote. And we'll get to something called slant asymptotes once we get into pre-calculus. And it really, if it's top heavy, it doesn't have a horizontal asymptote because it has a slant asymptote, like the equation of a line. So this one right here, so once again, that's a vertical shift. So we don't even need to pay attention to that. Okay, all we're looking at here is we're looking at the x's. Okay? So this one's bottom heavy, which means that it's y equals 0. Okay? So now we're going to do an example, and we're actually going to include holes in this also. So a hole is where a graph, so where you would draw a graph, and all of a sudden there would just be a break, and then the graph would continue on. Okay, so it's just a number that the graph doesn't touch. Okay, and holes are important, especially when it comes to vertical asymptotes and zeros. Okay, so the first thing I'm going to do here is I'm going to simplify this. So x squared minus 9 becomes x minus 3 times x plus 3. Okay, my denominator is x plus 3. Okay, so the first thing I do is I cancel. Okay, before I find horizontal asymptotes, horizontal asymptotes I don't even have to factor. But before I find vertical asymptotes or my zeros, okay, first thing I do is cancel. So that means that there is a hole at x equals negative 3. Okay, so whatever my value, I'm going to have to plug negative 3 in here and see what my y value is, but I know that it's not going to actually touch it, so I'm going to draw an open circle there. Okay, so let's go on ahead and let's plug that in. So negative 3 squared, okay, so negative 3 squared is going to be 9, let's see, so minus 3 is what? Negative 6. Okay, so approximately negative 3, negative 6. Okay, so there's going to be a hole. Okay, so our zeros are where we set this, our x-intercepts. Okay, zeros, remember, they mean the same thing. Okay, we set this equal to 0, and we solve, so we get x equals 3. So at positive 3, there's an x-intercept. It does not look like there's any asymptotes. The reason is this canceled and became a hole. So before you check for vertical asymptotes, you need to look for holes. Okay. Now let's see if there's any horizontal asymptotes. So we're going to go back to our original, and it looks like it is top heavy. So there are no horizontal asymptotes either. So now let's go on ahead and graph this thing. And like I said, I don't mind if you graph it on your calculator. Okay, but you need to make sure that you show me the work for finding these. Okay, so you show me, if it's a hole, you show me factoring, and you show me canceling these out. Okay, you can't just write it down and graph it and say, oh, these are the holes and asymptotes I found in my calculator. Okay, so when I graph this thing, I'm going to go into my y equals, and I'm going to go on ahead and graph x squared. So x squared minus 9 divided by, make sure you put a parenthesis around the denominator, plus 3. And let's see what happens. So I'm using a TI-83 here at home, and you can see that it's got a line going there. Now that is not correct. Okay, that line is not actually a vertical asymptote, okay, because we canceled that thing. Okay, so this graph is not going to look exactly like this. Okay, so let's go on ahead and let's draw an XY table for this. Okay, so the reason that this function looked silly is because we plugged it in its original form. Okay, but really we know that this is really f of x after it's simplified equals x minus 3. So it's actually a linear function, right? So our slope is 1 over 1, okay, and we're at negative 3 here. Okay? So we can go up 1 over 1, up 1 over 1, up 1 over 1, up 1 over 1, down 1, back 1, down 1, back 1, down 1, back 1. Okay, so here, remember I said that was going to be at about negative 6. Okay, so that's our hole. Okay, so now if we graph this thing, okay, it's just going to be graphed like this. Okay, so this hole right here we can leave. So you have to be really careful, when you're plugging these into your calculator, because your calculator doesn't know to cancel things out. Okay, so when we plug this in, okay, we want to plug it in as our basic function after we've simplified it. Okay, and there you're going to get that x minus 3. It's not going to show you the holes and stuff. Okay, at least for a function like this. Okay, so make sure that you do that, and the same thing. I mean, you can plug this in if you're left with a function, after simplifying that looks like x plus 3 over x plus 2. You can plug that into your calculator. Okay, that's going to be just fine. Let's this one right here, let's go ahead and plug this one in. This would be a good one to show you on. So we're going to do parenthesis. I don't know why I didn't show it to you before. So x minus 1 parenthesis times, oh, and I already forgot my first parenthesis. Remember I said you have to include that first parenthesis. Okay. Alright, so now we're going to have x plus 1. Okay. And now we're going to have close that parenthesis, divided by a parenthesis around both pieces. So now we're going to have x minus 2 times parenthesis x minus plus 2. Alright, so now let's graph this one. Okay, so now you can see this one. And you can see that mine actually draws these asymptotes kind of connected to it. Depending on your calculator, it might show you it might show you the asymptotes better, it might not. Okay, so mine, like I said, this calculator I'm using right now is a TI-83. I swap back and forth between a TI-83 and a TI-84. Okay, so make sure that, if you're going to do this, that's fine. Go ahead and graph it. Make sure that you graph it correctly. Okay, or you can do an XY table and plot some points. Okay, but make sure that you include your holes and your asymptotes. Draw those in. Okay, because otherwise, I'm not going to see them on your graph, and I'm going to count you off. Okay, all right. So that is it for Chapter 1. In Algebra 2. You guys practice and have a great day. I'll see you next time.